Hello and Assalamualaikum. So today our group are really excited to present to you about our project, the fast food ordering machine. It is an automated system that streamlines the ordering process. So let's dive into details. So before we dive into details, we need to know who is the person that involved to this project. So these are three persons that involved in this project. So let's dive in. So the background information for the project is the significance of designing an ordering machine lies in its ability to streamline the ordering process. Not just that, it enhances user experience and reduce errors associated that usually made by human with traditional ordering methods. So in nowadays we are in fast-paced technological landscape. Automated systems are increasingly relevant, providing efficiency and convenience in various sectors such as food service, retail, and logistics. So this ordering machine project aims to explore this modern application while addressing the growing demand for automation in everyday tasks. So, I will present to you our objective for this project. We have four objectives. The first one is we want to enhance the efficiency by minimize the wait time and improve service delivery. So next one, the second one, we want to make a user more easy to make an order by creating an intuitive interface that simplifies the order process for users. So the third one, we are reducing the errors that usually made by human. So we are minimizing the mistake in order placement through automated system. So number four is innovation. By exploring new technological solution that can be integrated into existing system. So this is the method overview designed for designing the ordering machine. So the first one on the left is roadmap for project execution, which is a block diagram. So the method for designing the ordering machine will be know the input. So the right one is our flowchart and the key steps in a design process. So this flowchart will guide us through the phases of the project and ensuring that each critical aspect is addressed effectively. By following this step, we can achieve well-structured and successful design process for this ordering machine.
Hello everyone, today I will be explaining the structure of a simple fast food ordering system written in C. This program consists of several key components including header files, constant, function prototypes, menu item and the main function. So let's go through them one by one. So first, header files and constant. We start by including three essential header files. First, studio.h for standard input and output function, stdlib.h for general purpose function like memory allocation, and string.h for string manipulation function. We also define a constant menu size with a value of 10. This ensures that menu size remains fixed throughout the program, making it easier to manage. Next, the function prototypes. So we clear our function prototypes with void display menu, close and open bracket, which shows the menu. Next, void take order, which takes user input for their order. and for the float display bill, which calculate and display the final bill. And lastly, for the void payment, which handle the payment process. Function prototypes help structure the program by ensuring that functions are declared before they are defined, improving readability and maintainability. Next is menu item and price. In this section, we define two array. So menu item open and close square bracket is a string array that stores the name of the food items. Next is price open and close square bracket is a float array that stores the corresponding prices for each menu item. So by storing menu items and their prices in arrays, we can easily display and access them when needed. Now for the displaying the menu. So the display menu open and close bracket function loops through the menu items open and close square bracket and prices open and close square brackets array to print a numbered list of item along with their prices. This makes it easier for the customer to select items when placing an order. So next is the main function. The main function serves as the core of our program. So here's how it works. First, it displays a welcome message. Second, it uses a while loop to allow multiple orders until the user decides to stop. Then, it calls display menu open and close bracket to show the menu. After that, it calls take order open and close bracket to take user input. Next, it asks the user if they want to continue ordering. If not, the loop ends. After that, it calls display bills open and close bracket to show the final bills. And then it calls the payment close and open bracket to complete the transaction. And finally, it displays a thank you message before exiting. This structured approach ensures a smooth and user-friendly ordering experience. So now let's move with the function that displays the bill. This function loops through the order open and close square bracket array to check which item was selected. For each ordered item, it calculates the total cost based on item's price and quantity. Then it displays a summary of the order, including the item's name, quantity and total cost. Finally, it prints the total bill amount and returns it for further processing. This ensures a clear breakdown of the purchase for the user. So now let's move to the last one, which is processing payment. So I just explained the code here. So we see once the bill is generated, the next step is processing the payment. The payment open and close bracket function handle this. The user is prompted to select a payment method, either a debit card, credit card or cash. If a card payment is selected, the system asks for a card number and PIN, simulates processing and confirm the payment. If cash is chosen, the user enters the amount and the system checks if it's sufficient. If the cash amount exceeds the total, the change is calculated and displayed. If an invalid payment method is entered, the system prompts the user to try again. This will ensure a smooth and secure transaction process.
Okay, now I will continue at methodology. Method step 1 is overview of the block structure. The fast food ordering system consists of 4 major functional blocks. Menu display shows available items and their price. Order processing takes user input, validate selection and update order data. Billing systems calculate the total cost of the selected items. And lastly, payment processing handles different payment methods and complete the transaction. Now for method step 2, simulation the result. We conducted a step-by-step simulation by executing the program and observing different scenarios. Scenarios 1, successful order with cash payment step. Number 1, the user select pizza 2 units and fries 1 unit. The system display the total cost pizza 2 times 8.99 plus fries and the total is $20.97. And number 3, the user select cash payment and enters the value $25. And last, the system process the payment and returns as change. And next method, step 3, discussion on finding keys. Number 1, user-friendly experience. The program correctly displays the menu and guide the user through ordering. Clear prompts help users make selection efficiently. And then input validation. The system handle invalid input such as wrong item number, negative quantities. Ensure correct payment details before processing. And next, accurate billing. The calculations are correct for different order combination, and the final bill display item with quantity and total price. And lastly, secure payment handling. Card transaction must sensitive details. It's showing only the last 4 digits. It prevents invalid payment by enforcing PIN validation. And this method step 4 is the last. That is visual aids for presentation. This block diagram usually represent the flow of the program. First, start it with display menu, and then take order, display bill, payment processing, and lastly order confirmation. And we go for the conclusion. Reflection on the ordering machine project. Performance data presentation. The project culminated in a successful ordering machine that met its design objective. Performance data collected during usage indicated increased efficiency in the ordering process, high user satisfaction, read positive feedback on this machine. Functionally, this result highlight the project success and its potential impact on future automation initiative. So that's all from our mini project. Thank you.